Hello there and then welcome to Hub Beyond Numbers, where we learn maths the easy way. Now in this video, which is an introduction to this playlist, we are looking at position and then transformation. And in this particular video, we want to understand what we mean by transformation, right? Transformation. And then we'll identify what rigid motion is as well. After which, I'll now explain how to identify points on the Cartesian plane, because we are really going to need that if we want to transform figures on the Cartesian plane. So without much ado, let's quickly go into it. So to start off, let's take this figure I have over here. Now you realize that if I highlight and then I move it in this direction, you see there's a movement, yes, and then the movement it is undergoing is changing its position. You see, so initially if it was here and I move it towards this side, I have changed its position. The same way, I've also changed this position. Okay. Now, if I decide to move it this way, and after which I do something like this, it's like I've changed the shape. You see, its orientation. Let me say that. I have changed its orientation as well. Exactly. Now, what if instead of that, I now come and then do something like this? In this case, I have enlarged it. All this is what has got to do with what? Transformation. So we have transformed this figure to look so many ways. Its position, its size, and then its orientation as well. So let's define what transformation is. So we say a plane figure undergoes transformation when there is a change in its position. Take note, its position, its size, or its shape. So if you have a plane figure and you end up changing its position or size or shape, then you can say it has undergone transformation. Now, with this definition made clear, then we can say there are some types of transformations, right? So we'll be looking at reflection, then rotation, we have the translation, and then we would also finally look at enlargement, right? So before we look at it, or these, let me give you a gist about what they all represent. So let's just draw a mini Cartesian plane over here, something like this. And then I have this as well. So with this now, if I put this shape over here, right? And talking of reflection, if we are going to reflect this shape, then all it's going to say is this line here is a mirror line, and hence it will just flip over something like this and come to the opposite side. That is what reflection will do. On the other hand, if we're talking of rotation, then all it is going to do is to do what? Change its orientation, something like this, you see. So any of this orientation, it means you have what? Rotated it, right? So that will be rotation. Talking of translation, when you translate it, then you are moving it. You are moving it in any direction, you see. That is what translation. Then finally, just as we did previously, if we are talking of enlargement, then enlargement on the other hand is going to change this whole thing over here, right? It is going to change the shape, you see. So it's going to change it to something like this, something bigger, right? Now if you take a look at all that I have explained over here, you realize that for reflection, the shape, and then what do you call it, the position. So if you take a look at this we did over here, which we said reflection, rotation, and then translation, you realize that it is only the position that was changed, right? It was only the position that was changed. That is, if I'm comparing this one here to this, it is only the position that has been changed. Same applies to this. It is just the position that has been changed. The size has not been changed, neither has the shape been changed. You see, so whenever a shape undergoes a transformation such that it is only the position that was changed, such that its size and shape does not change, then we call it a rigid motion. You see, we call it a rigid motion. So with all this we have over here, we are going to say that reflection, rotation, and translation are rigid motions. Why? Because they don't change the size and then the shape, right? They don't change the size and then the shape. So this is just an introduction on transformation. We've gotten to know what transformation is, when the shape, size, and then the position changes. And then we are getting to know that if only the position is what's changed, then it is a rigid motion. All right. Hence, enlargement is not a rigid motion, because it will definitely change the size. It will also change the shape. You get it? Okay. With that said, in our subsequent videos, we'll take reflection alone, talk about it, and look at the mathematics behind it, same as rotation and then same as translation, and also enlargement. But for the continuation of this, well, let's look at how to locate points on the Cartesian plane. So talking of the Cartesian plane, this is the Cartesian plane over here. Now, the Cartesian plane is a two-dimensional grid formed by the horizontal axis and then the vertical axis. You see, so you'd see that there's this vertical axis here and then there's a horizontal axis here. We call the vertical axis the y-axis, and then we call the horizontal the x-axis, right? So now they intersect at the origin. This is the point where they intersect, and we call it the origin. And its coordinate is what? 0, 0. This here, 0, 0. Because at that point, the value of x is 0, and the value of y is also 0. And hence we call it what? The origin. Now, the plane is divided into 4 quadrants. It divided into 4 quadrants. This here is your first quadrant. This here is your second quadrant. You have your third quadrant here, and then your fourth quadrant here. Take note of how it is. That is anti-clockwise. So this is your first quadrant, your second quadrant, your third quadrant, and then your fourth quadrant. Let's look at what each quadrant is. Let's look at the numbers in each quadrant. So for the first quadrant, our x-axis has positive values over there. You see, so as I said earlier on, this over here is our x-axis, and if we want to label it, then we are going to have the values 1, 2, 3, 4, and then 5. And then on the left hand side, we are going to have negative values. So -1, -2, then -3, -4, and -5. You see, let me label the y-axis as well. So this is my labeled axis. On my first quadrant over here, you realize that I have only the positives of the y-axis and then the positives of the x-axis as well. You see, so in my first quadrant, the x-axis are positive, y-axis are also positive. Let's look at my second quadrant as well. So for any point in this second quadrant, it is always going to take from the negatives of the x values, you see, and the positives of the y values, right? So that is that. You have to take note. For this third quadrant, it is made up of what? Negative values of my x-axis and negative axis of my what? Y-axis as well. So in the third quadrant, we have negative, negative. Then on my fourth quadrant, we have positive x values and negative y values. So these are the characteristics of the various quadrants we have in the Cartesian plane. Now let's look at how to plot a point on the Cartesian plane.